All right, so absolute value inequalities, this is the quick review. So we've already taught the full lesson. Let's get to the quick review. All right, first off, you need to properly read the inequality symbol. You need to properly read the inequality symbol. And technically, you read it after you isolate the variable. All right, so let's do that. Or, I'm sorry, the absolute value. So let's isolate the absolute value. Let's go ahead and add a -1 to both sides. That'll be a 20. Let's divide both sides by 4, and therefore the right-hand side will be a 5. Okay? And so when we have the absolute value of n minus 2 is less than 5. At the point where you've isolated the absolute value, we can now read our inequality symbol, and it's a less than. So you have to remember that less thans are what? A conjunction. And what's the key to understanding a conjunction? What kind of solutions do you get? You get the intersection. So you have to understand, hey, I get the intersection. Okay. In this kind of a situation, because the right-hand side is positive, these are going to overlap going in different directions. That's the way it works. Now, I can solve each absolute value inequality, and I'll do it that way. So, remember the first time, you just simply remove the absolute value inequality and solve. So we get n less than 7. Okay, I'm going to keep the word n because it's a conjunction. Second time, remove the absolute value, place a negative in front. Right? And I do this to help my students to remember that this absolute value symbol is going to switch. All right, add a -2 to both sides. Right, and then to take care of the negative n, divide both sides by -1, and you remember therefore to reverse the inequality symbol, right? Okay, so here are my two inequalities. Let's graph them and take a look at what that looks like. Okay, so n is less than 7, so oops, we need one more for a 7. Circle over the 7, arrow to the left, greater than -3. Circle over the -3, arrow to the right. And you see how the conjunction is going to be every value from -3 to just before. So any value just greater than -3 up to just less than 7. And again, do you remember how to write that? So your written solution is going to be -3 less than n less than 7. So again, just take your bigger one, write it as it is, flip that symbol, put the smallest number in front. Right, that's the idea, and that's our solution. Now, by the way, you could have also remembered that 2 is the midpoint, right there, right? Midpoint. And you could have remembered to go 5 to the right. Oh, wow, that gets me to 7. And 5 to the left, and oh, wow, that gets me to the -3. Again, understanding that it's the intersection, and you could have written the inequality. All right, if you can't do it that way, just graph it and away you go. Okay, so that's a conjunction. Then the possibility is also there for a disjunction. So again, right now I'm really not quite ready to read that it's a disjunction. Let's go ahead and isolate the variable, and you can see we end up with the exact same thing, only the symbols go in the other direction, right? The absolute value of n minus 2, and it's 5, but only this time it's a greater than. And by the way, it wouldn't matter if it's greater than or equal to, so let's do it that way. Why not? All right, greater than. So now you must understand, hey, this is a disjunction. And again, all disjunctions have solutions as the union. Okay, so again, if you solve, notice you get the exact same thing, right? You get the exact same thing, only your symbol's backwards. So watch. Okay, so again, remove and solve, greater than or equal to 5. You get n greater than or equal to 7. Here I'm going to graph as I go. So this is a, I hate that. This is a dot over the 7, arrow to the right, right? Now when you do the other one, again, you're going to put a negative out in front. All right, distribute. Right, add a, so this is -n plus 2, add a -2 to both sides, you get 3, divide both sides by -1, reverse your symbol, right, and see now how you're less than or equal to -3. So do you remember how to say that with a disjunction? you write the smallest one first, n less than or equal to -3, and the word or, and then n greater than or equal to 7. That is always going to be the case. Now, there are a couple possibilities. What if when you isolate the absolute value, this other side is negative? Okay, then that's going to cause you to have a situation with a conjunction of no solution, and a disjunction, if that were to happen, with a solution of all the real numbers. Okay, that covers all four possibilities. I think absolute value inequalities are really, really cool, but to do them, you have to fully understand conjunction and you have to understand disjunction.